Section C, moles.
First, a little context. Atoms and molecules are so extremely, unbelievably small that even the tiniest samples of matter contain unfathomably large numbers of atoms or molecules. To handle those tremendous numbers, chemists use a weird-sounding unit of measurement called the mole. A mole is a unit of measurement that represents 6.022 times 10 to the 23rd things. Yes, things. Moles are designed to measure atoms, molecules, ions, electrons, sesame seeds, or tiny things like that. But if you wanted to, you could talk about a mole of beer nuts. Of course, a mole of beer nuts would cover the entire surface of the earth. Think of the term mole like the term dozen. You know that a dozen refers to 12 things. 12 eggs, 12 donuts, whatever. A mole refers to 6.022 times 10 to the 23rd eggs or donuts or atoms or molecules, whatever you're measuring. The magic mole number, 6.022 times 10 to the 23rd, is also known as Avogadro's constant, not to be mistaken for avocado's constant, which is really just a recipe for guacamole.
How many particles are in a mole?
6.022 times 10 to the 23rd power.
So the mole, like scientific notation, makes it easier to deal with humongous, unwieldy numbers. A mole of moles, for example, would be more than 60 million billion moles.
So the mole is basically just a way of keeping up with huge amounts. 1 mole of atoms has 6.022 times 10 to the 23rd atoms. And if you have 1 mole of water molecules, you'd have 6.022 times 10 to the 23rd molecules. This is tricky, so listen closely. In that mole of water molecules, you'd have 3 moles of atoms, since each water molecule consists of 3 atoms, 2 hydrogens and 1 oxygen. In 1 mole of water molecules, there's 1 mole of oxygen atoms and 2 moles of hydrogen atoms.
And here's another cool thing about moles, right? 1 mole of any type of atom has a mass in grams equal to the atom's atomic mass measured in AMUs. Pretty cool.
When you look up the atomic mass of carbon in the periodic table and see that its atomic mass is 12.01 AMUs, you know instantly that 1 mole of carbon atoms weighs 12.01 grams. You look up iron, Fe, and see its atomic mass is 55.847 AMUs, you know that 1 mole of iron atoms weighs 55.85 grams.
It's that easy, which is a good thing, because you will have to use this conversion constantly as you convert back and forth between moles and grams.
Replay! The gas xenon has an atomic mass of 130.30 AMUs. So a mole of xenon atoms weighs 130.30 grams.
Now let's talk about molecular mass and molar mass. Molecular mass is the combined mass of a group of atoms forming a single molecule. Add up the masses and AMUs of the atoms forming the molecule, and you have the molecular mass.
Molar mass equals the mass of 1 mole of a substance. Molar mass is the mass of 1 mole of a single type of atom. If the substance you're measuring consists of molecules, the molar mass is the mass of 1 mole of the molecules.
When you do calculations, you'll usually measure both molecular mass and molar mass in grams per mole, which is how many grams 1 mole of whatever substance you're using would weigh. For instance, when you read that the molecular weight of carbon dioxide, CO2, is 44.01 grams per mole, it means if you had a mole of these carbon dioxide molecules, it would weigh 44.01 grams.
Now, if we want to, we can express the weight of a single molecule. To do that, we use AMUs rather than grams per mole. We'll do an example showing you how to find the molecular weight of carbon dioxide, which we've already told you is 44.01 AMUs. Then we'll convert our answer to grams per mole.
So let's find the molecular mass of carbon dioxide in AMUs. Molecular mass equals the sum of the masses of the atoms in the molecule. So the first thing we have to do is look up the masses of the molecule's component atoms in the periodic table. Carbon has a mass of 12.01 AMUs, and oxygen has a mass of 16.00 AMUs.
CO2 is made of one carbon atom and two oxygen atoms, so the mass of one molecule of carbon dioxide equals the mass of one carbon atom plus the mass of two oxygen atoms. According to the periodic table, the mass of carbon is 12.01 AMUs, and the mass of oxygen is 16.00 AMUs. 1 times 12.01 AMUs plus 2 times 16.00 AMUs equals 12.01 AMUs plus 32.00 AMUs. That gives us 44.01 AMUs. But like we said, you won't use molecular weight in AMUs very often. Most of the time, you'll need to express the weight of a single molecule in grams per mole. So we'll make that conversion now. It's the easiest conversion you'll ever have to deal with.
Hey, to convert from AMUs to grams per mole, you literally just change the units from AMUs to grams per mole. We'll show you.
Since 1 mole of any type of atom has a mass in grams equal to the atom's mass measured in AMUs, the numbers don't change when you convert your units to grams per mole. Here's the calculation of the molecular weight of carbon dioxide again, this time using grams per mole instead of AMUs. Notice that it looks exactly the same as the calculation we did earlier using AMUs. We've just written in the units grams per mole, where earlier we had AMUs.
Now we're ready to find the molar mass of a substance. This process is going to look real familiar. Now remember the difference here. Molar mass refers to the mass of 1 mole of molecules. Molecular mass is the mass of 1 molecule. Let me say that again. Molecular mass is the mass of 1 molecule. The calculation for molar mass looks exactly like the calculation for molecular mass, but the molar mass is always expressed in grams per mole, since we are, in fact, dealing with an entire mole.
The molar mass of water molecules, which is the mass of 1 mole of water molecules, equals the mass of 2 moles of hydrogen atoms plus the mass of 1 mole of oxygen atoms. So, we will add 2 times the atomic mass of hydrogen plus the atomic mass of oxygen. That's 2 times 1.0080 grams per mole plus 1 times 16.00 grams per mole. 2.02 plus 16.00 equals 18.02. So, the mass of 1 mole of water molecules, known as the molar mass, is 18.02 grams per mole. Why? Because the numbers you use for AMUs and grams per mole are the same.
So, use grams per mole in calculations, whether you're calculating molecular mass or molar mass. It's that simple.